All right, hey everybody, and welcome to this concept guide, the 8-1 about the geometric mean in right triangles. So just to remember, the means of the proportion the same, we call that a geometric mean in an extreme as we get into this. So for example, 2 over 4 equals 4 over 8. 4 is a geometric mean because the means of the proportion are the same. 4 is the geometric mean between 2 and 8. With variables, b is the same as the means, a over b equals b over c, so b is the geometric mean between a and c. That's what it means to be a geometric mean. So we've already learned how to find the geometric mean between things. So to find the geometric mean between 5 and 10, what do? We can write a proportion and then cross multiply and then take the square root, and then we'd get 5 square root 2 once we solve. We can also jump straight to here. It's always, the geometric mean will always be the square root of the product, the square root of 50 in this case. Okay? So that's how we find the geometric mean. So question B, for example, the geometric mean is the square root of 6 times 15, which is square root of 90, but don't build up, which you're going to tear down. So that's 2 times 3 times 3 times 5. 3 comes out, the 2 and the 5 stay in. And then this example, geometric mean between 3 and 12, x is equal to the square root of 3 times 12, which is 36, or 6. If you did break that down, you should have pulled out both a 2 and a 3. Okay, so that's how we find a geometric mean. That's what a geometric mean is. Now, that is very related to this shape right here. But to help make sense of this, let's use our knowledge of, well, similar triangles. I got this blue triangle on the right, I got the yellow triangle on the left, and I got the biggest triangle. All three of these triangles have a right angle, and the yellow triangle has this angle that's marked here in red, and the biggest triangle has that angle marked in red, and then the blue triangle has that same angle that's marked in red. So as a result, all three of these triangles, the blue one, the yellow one, and the biggest one, are all similar thanks to angle. All right, that being said, I'm going to list all the sides of the smallest triangle here in this chart from smallest to largest. So from the smallest triangle, the smallest side is G. The next biggest side is A, and then the hypotenuse, the longest side, is M. And yeah, do go by how it looks in this case right here, the G-A-M. For the medium triangle, the yellow one, the smallest side is A, the medium side is F, and then the biggest side, the hypotenuse, is K. And I'll do the same thing for the biggest triangle, that's M is the smallest, K and H. Right? Now, take a look at what just happened. We got this stuff here. These are similar triangles. These actually are all corresponding in some way. This is the smallest side, the smallest side, the smallest side. Notice that A, M, and K show up twice. They got two roles here. A is a side, it's the smallest side of the yellow triangle, the one on the left, and it's the medium side of the blue triangle, the one on the right. K is the medium side of the biggest triangle and hypotenuse of the one on the left, the yellow one. And M is the hypotenuse of the blue one, and it's the smallest side there. There's dual roles. That's why K, A, and M show up twice. As a result, I can write this proportion. G over A equals A over F. Those are corresponding parts of similar triangles. And that's a consistent version of this. So look at this. A, this altitude, is the geometric mean between the two parts of the hypotenuse. Not the whole hypotenuse, but the two parts. The whole hypotenuse here is H of the biggest triangle. The parts of the hypotenuse of the biggest triangle is F and G. But F shares a triangle with both F and G, those parts of the hypotenuse. It's a geometric mean. Okay? Likewise, K is a geometric mean. K is a geometric mean between F and H. And then M is a geometric mean. I have to, the G over M will equal M over H. We get another proportion. So those are all geometric means. K is a geometric mean between F and H. M is the geometric mean between G and H. So in other words, the legs of the biggest triangle, like K, is the geometric mean between the part of the hypotenuse it's closest to and the entire hypotenuse. M is the geometric mean between G and H, the part of the hypotenuse it's closest to and the entire hypotenuse. That is how we can answer these questions really quickly. So check this out. In my example, Y is an altitude of the biggest triangle. The altitude is geometric mean between the parts of the triangle. So I get to write this proportion. 4 over y equals y over 5. Y equals square root of 20, y is 2 square root of 5. Pretty quick, actually. Now to solve for x, x is a leg of the biggest triangle, so it is a geometric mean between 4, the side that it's closest to, and the entire hypotenuse, which of course is 9. So x is the geometric mean between 4 and 9. X is the square root of 36, or 6. That's it. There's my example. Go ahead and see if you can apply it. I'm going to show you the answers to number 1, but not for number 2. Pause the video if you haven't. Try number 1. And here are those answers. Hopefully you got those. If you didn't, try to figure it out real quickly. But we'll talk about it in class. Have a great rest of your day. Take care. Be healthy.